My research objective is to develop a semi-automated approach to support diagnosis of HVAC problems during HVAC corrective maintenance tasks. Why do I focus on HVAC corrective maintenance? First of all, corrective maintenance is important because it takes more than 55% of all maintenance programs in the United States. And HVAC system is important because it accounts for 40% of a building's total energy consumption, and it controls indoor environment quality, which has positive correlation with occupant health and productivity. HVAC system is so important, but maintaining and troubleshooting HVAC related problem is difficult. Facilities Management Service Center always receive all different kinds of complaints from occupants about their indoor environment, such as too hot, too cold, too stuffy, odor, too loud, humidity too high, too much air, no air, it's leaking, etc. And the complexity of HVAC related problem is that even for the same type of problem symptom, in different types of systems and associated spaces, the root causes are very diverse. For example, for too hot problem, in one space, it could be because the room has big windows and sun radiation is too high. In another space, it could be because too many occupants. In other spaces, it could be failure of HVAC components such as thermostats or reheat valve. It could be because unusual operational activities such as shutdown of air handling unit. It could also be as simple as that air diffuser is too close to occupant. I like to quote a description about the difficulty of diagnosing HVAC related problem. Investigating indoor air quality problem is like detective work. Clues and evidences are obtained, a picture begins to emerge, and the conclusions may eventually be drawn. In some cases, no exact culprit may become apparent. A case study has been conducted with the purpose of understanding expert HVAC mechanics' decision-making process of diagnosing HVAC problems for corrective maintenance work orders. The study involved shadowing work of 23 corrective maintenance work orders with an expert mechanics in multiple university campus buildings, and it also involved questionnaires and follow-up interviews with 6 other HVAC mechanics and reviewing of historical work orders. So, what is the current workflow to complete a HVAC corrective maintenance work order? First, the occupant complaint. A work order is generated, and the HVAC mechanic who is assigned with the work order will go to the job site to investigate the problem. He firstly needs to do a general inspection to eliminate non-system failure factors, such as space type changed, wrong thermostat set point, unusual operational activities such as steam shutdown, etc. After non-mechanical failure factors are eliminated, the mechanic will do a detailed inspection to decide which components or parameters need to be checked. He needs to know what type of HVAC system it is, how it is controlled, what building automation system it is using, and the maintenance history of this system and space. After he decides which components or parameters need to be checked, he will run a series of testing to identify problem and fix the problem. We can see that the value-added part is the last 2 phases, identify problem and fix problem. But in order to identify the problem, the HVAC mechanic needs to collect information to narrow down the search space. However, case study shows working efficiency highly dependent on HVAC mechanics' personal experience and familiarity with the system and space. The HVAC mechanic only needs less than 15 minutes to identify problem sources with familiar systems and spaces, while the same process took 2 hours or even longer with the unfamiliar system and spaces. The reason is that in current practice, the required information items are identified in a manual and ad hoc manner, mostly during field inspection, ad hoc communications such as phone calls, and through personal experience and familiarity. The diagnosis efficiency is significantly affected if there are access problems or there's a lack of experience and familiarity. Therefore, in order to deal with the problems, my research aims to develop a decision support system to automatically generate required information for a given work order so that HVAC mechanics can identify the problem sources more efficiently. To develop such a system, I need to answer 3 research questions. The first research question is, what are the information requirements that HVAC mechanics need when diagnosing HVAC problems for a corrective maintenance work order? Second research question is, what is the representation schema and reasoning mechanisms to enable automatic identification of required information? And the third research question is to answer how to visualize the identified information which is critical for HVAC diagnosis. The envisioned contributions are information requirements for HVAC corrective maintenance activities, a formalism to represent these information requirements in relation to building information modeling, a reasoning mechanism of automatic identification of required information for a given HVAC corrective maintenance work order, and an evaluation of different visualization techniques to display required information for HVAC mechanics to support HVAC corrective maintenance tasks.